Now I'm working on G4 warm-up. Brandon rolls a fair pair of six-sided dice. Each die has values from 1 to 6. So they look like normal die, you know, the ones that you play D&D with. Well, actually, you play with fancy ones in D&D. But the ones you play Monopoly with. He rolls an even number on his first roll. What is the probability that he will roll an odd number on his second roll? Well, first of all, what are the numbers on die? They are numbered, the sample space is 1 through 6, and they're all equally probable, so no one's more probable than the other. So how many of them are even? Half of them, 3 out of 6, right? So probability of rolling an even at any time is 3 out of 6. Probability of rolling an odd is also 3 out of 6, right? And says, what is the probability that he will roll an odd on his next roll? It's really only asking for this, which is 1/2. Why can I ignore the first roll? It told me what happened. It's not really part of the equation anymore. So it's just A. Now, if they had asked me, what is the probability he will roll an even and then an odd, then I could actually multiply these two products together. A bag contains 5 red balloons, 10 orange balloons, 8 green balloons, and 12 purple balloons. If a balloon is drawn from the bag at random, what is the probability of orange? So the probability of orange is basically the number of orange outcomes, I'll leave outcomes off, over the total. Alright? So how many are orange? There are 10. What's the total? There's 5 plus 10 plus 8, 12. These are 20. Plus 30, 35. So it's 10 over 35. Now, I can there's no 10 over 35 here. They sort of like, they're trying to lure me with these. Maybe those are right. I don't think so, because that looks like bigger than those fractions. So I can simplify it. This is a cool way to simplify. I know 5 goes into both of those. Both of these are divisible by 5. 10 divided by 5 is 2. 35 divided by 5 is 7. So my answer is 2 7s. Last but not least, which of these numbers could be a probability? Probability can be anywhere from 0 to 1, inclusive. All right? So you can have 0 as a probability, and you can have 1 as a probability, right? So which of these numbers could be a probability? It's not this one, because that's negative. See the sign there? This is greater than 1. So is this. So that would be the correct answer.